Bright Tuty. Every student matters.
Hello students, welcome to this session. Today we are going to do a very important chapter that is named Motion and Time. Now when I say what is motion, we have to understand it by understanding looking around. We will be defining motion by looking at our scenarios and surroundings around us. Then we are going to understand how time is related to the same. So let us begin with the session. So number one, people, when you were in the previous class, that is in class number 6, you have learned about different types of motion, calling periodic motion, the motion that is going in a circle, the motion that is happening in a straight line. All these are different types of motion. But when we talk about motion, what is it? This is what we are going to recall while understanding the three different types of motion as we have referred here as what students? As circular, periodic, that is similar, or straight line motion. Fine. Let's go and understand and have a table here. So let's say we have a table named 13.1 in your books that gives some common examples of motion. Now here it is crucial that we at least come to define what is motion. So people, when we define motion, it is defined as movement. Very important. Yes, it is defined as movement. If I have to be more particular, I will say it is the change in position. The change in position of an object or a particle of a particle or an object, even a change in orientation. All of these comes under my definition of motion. Now when motion happens, we know time will be lapsing. It will going on. So we can say that movement happens with respect to time. Now you're getting it why we had the term time with motion there. So in table number 13.1, we are going to identify the different kinds of motion as we see in our surroundings. Let us begin with the very first one. Soldiers in a march past. What kind of a motion it will be, students? If they are marching past, we know that they will be going together in sync in a straight line. Hence, it is my straight line motion. So, if you refer to what is straight line motion, let us write the definition as well. So, when the change in position of a particle is in straight line, so writing it, when the position of an object or a particle is in a straight line only, that is moving straight in one line, that is linear, we call it straight line motion. So definitely soldiers in a march past straight line motion. Next is bullock cart moving on a straight road. Now if the bullock cart is moving on a straight road, we definitely get to know the bullocks are going on a straight line only. So hence the answer to this also comes out to be straight line motion. Let us figure out the other one. Hands of an athlete in a race. So people, what you have seen when an athlete runs, whenever we run or jog or walk in a pace, we always do this in a very rhythmic manner. Hence, we can call it the periodic motion. Now here comes another chance for us to define and remember what is periodic motion. So people, talking of periodic motion, if a motion is if a motion of a particle or an object is repeating itself in a given time, we call it periodic. So let's see, every 1 second your left hand goes up, then next second your right hand goes up, then your hands of an athlete or us being jogging will be same, that is periodic motion. Now the next one is pedal of a bicycle in motion. So people, what is pedal in a bicycle doing? It is executing circular motion. So here comes, if a body, if a particle is moving in a circle, definitely it will be periodic because the circle carry on in same circumference over equal interval of time. It passes on the same points. So if a particle is moving in a circle, it is said to execute circular motion. Right? So if you have ever seen the pedals, you must know that that is circular motion. Motion of the earth around the sun. Definitely, if I have to write, it is circular as well as periodic. Definitely not straight line because it's circular, but it is periodic because it repeats in a fixed value of time. Motion of a swing, again going swing up, down, up, down. We call it the periodic motion, repeating itself over a fixed interval of time. Motion of a pendulum, it's very, very similar to the swing. Actually, I should say the vice versa. A swing is very, very similar to the pendulum. So, the motion of the pendulum is also periodic motion. So, people, here we have actually figured out all the three types of motion which you have already done in class 6. Let's see what we see in our day-to-day life. It is a common experience that a motion of some objects is slow while some are fast. Do you remember that story of the rabbit and the turtle? Do you remember the story of the rabbit and the turtle? So when the rabbit was running and the turtle was having a race, we all know who won it, right? Who was the winner of this race? But we know while the winner is someone else, the faster one was someone else. So if I have to tell you who was faster, Mr. Rabbit was faster. But who won the race? Because of the consistency, the turtle wins the race. But talking of it, if we talk about turtle, turtle was definitely slow in the race. Still he wins because of consistency. So this was a Panch Tantra story that actually helps us to understand how doesn't matter how slow you will move, but your consistency will make you win. But apart from this, we have to take it from the physical point of view. So we understand that many objects execute motion in different pace. So some objects are slow while some others are fast. So when we talk about motion and talk about slow and fast, we are actually talking about pace of motion. How motion is happening. Is it going slow or is it going fast? Now we are going to understand what does the slow and fast actually mean. In layman language, we already know if you are moving faster, you will be covering some distance quickly. But if you go slow, the same distance can take you more time. So let us just see what we can understand here. We know some vehicles move faster than the others. For example, we all know aeroplanes are the fastest mode of transportation we know yet. Then we see that trains come, bullet trains, all those we see as the land. Then we see that the vehicles, even in cars, some are faster, some are slower, right? The slowest we got to know is the ships, the water transport, which goes very, very slow, right? Even the same vehicle, talking about a train, it is not meant to go with the same speed or at the same pace. It moves faster or slower at different times. So let's say when it has to push the boundaries and it has to reach a destination sooner, it will go faster. But when the train is reaching the destination station, it will go slower because eventually it has to stop. So even a same vehicle, not just different, but even a same vehicle can have different pace of the motion, right, at different times. Now, if we talk about talking 10 objects moving along a straight line path, We can talk about anyone. I can move in a straight line path, a car, a scooter, a scooty, a cycle, a train, a bus, right? We can see many objects. Even our aunt, though may not go in a straight line, but yeah, there are lots of examples that we see around the bullock carts. In the bullock carts, the bullocks were going straight. So there are many examples where we can see that motion executed by an object is in straight line. But when all these objects have to be undertaken under two headings, one is slow and one is fast, how we will decide this? How will we know that the scooter was faster or the car, or the bullock cart or the auto rickshaw? How we will ever get to know that? If we need to decide whether the body is moving slow or body is moving fast, we must have a parameter to measure it. So as I say, like for giving you an example, people, let's say I say, Mama, I'm feeling feverish, right? So that is just a vague term. Slow and fast is like that. But if Mama brings a thermometer and measures my temperature and tells me exactly that my temperature right now is 100.5 degrees Celsius, then what it will be? My temperature is exactly that. So yes, I can tell you the value and that is measurable. Similarly, the pace of the motion is also measurable. How we can do that? We are going to learn it. So if vehicles on a road all are moving in a straight line on the road. So people just take a simple example. Let's see, we are having a race of all those 10 vehicles we just listed. The bullock cart, the auto rickshaw, the cycle, the scooter, the car, the bus, the train, all of them are racing up. We can easily tell if they're starting from the same point and going to go in the same direction and go and correct the finish line first. That will be faster. The one who will be slower will be coming second, third, fourth, and the last one will be the slowest, right? So from start to finish, we can tell. But do vehicles move like this? Okay, let's have a competition. Let's see who's faster or not. It is not like that. So it is not easy to tell who's faster or who's not if the vehicles are not moving in a straight line, taking a race from the same point. Then what we will do? At this time, the motion of the vehicles moving on the road, we will look at it. Okay, so we will look at how we can figure out. So people, let's do an activity for that. Look at the figure of 13.1. Shows the position of some vehicles. So let us just get to the figure first and then we will get back. So what is happening, people, in this figure? There is a car. So let's say it's A, it's B, it's C, it's D, it's E, it's F, it's G, it's H, and it's I. So there are 1, 2, 3, 4, 5, 6, 7, 8, 9 cars running in the same direction. Still, who is faster, who is slower, can we tell? Let's see by the activity. So we are here to learn the things by the activity. Right, people? So in the activity, what we have, look at the figure. There are 9 cars as we see. So they show the position of some vehicles, to be very precise, 9. We have named it to A to I. Right? Moving on a road in the same direction at some instant of time. So obviously, if we are looking at the practical life, the cars which are looking at, it will go and rush to the other position. But if I pause, if I click a picture of the road at a point, that is the scenario which is shown. Now, let's look at 13.2. So we have just seen at one of the figure, bacha. So now we are going to see what happens in the second figure. Okay, now things have changed. Look at the first figure. Look at the positions of A, I, and H. Where is A? Where is I? Where is H? Everything seems to be shifted, right? The I has shifted more. The A is there. I can see that H, right? It was D. My D, that is the green car, has moved forward. Lots of things have changed. So what have changed? I told you at the same time, if I see all the cars at the same time, it may be at one position. The next moment, the scenario could be totally different. So in figure 13.2, students, we show that the position of the same vehicles after some time. So let's say in 2 seconds, I click another picture and the scenario have changed. What did you find? What are the observations? Chalo. Let's see whether we can answer this or not. Which vehicle is moving the fastest of all? Now, talking of that, we have to again look at the picture, look it very carefully, and maybe we will be able to answer or may not be. If I ask which one of them is moving the slowest, again, by looking at the picture, we may or may not be able to tell, because a vehicle which have reached the maximum distance in less of the time will be the fastest, but which is still at approximately the same position or has just shifted a bit will be the slowest. Now, to answer it, as I told you, the example of thermometer and the temperature, we have to be more particular. So, how we get more particular? The distance moved. We always look at the distance moved by the objects in a given interval of time. That is where we can decide which one is faster and slower for sure. So, what is the part, kids, that we actually have to understand? What is the distance traveled by all the cars in a given interval of time? So these two things matter the most while knowing the pace of the motion. For example, imagine that you have gone to see off your friend at the bus stand. Suppose you start pedaling your bicycle at the same time that the bus begins. So you are just seeing off your friend saying bye and you start on your bicycle, now you're going. But at the same moment, the bus also starts, right? The both of you are moving in the same direction for some time. So the distance covered by you after 5 minutes would be very, very small. You are going on a cycle. How can you compare with a bus? For the bus, the distance will be very, very great in the same interval of time. This is how we can say that the pace of the bus moving is faster as compared to the cycle. Now, would you say that the bus is moving faster? I will say, if we can have this, if this question comes in my hand, in my mind, that yes or no, the answer will be a big yes. The bus has covered greater distance in less time or in equal time. Hence, we will call it is moving faster. We often say that the faster vehicle have higher speed. So the term here we have to refer is speed. In a 100-meter race, student, it is easy to decide whose speed is highest. One who takes the shortest. So as we have done the race of the vehicles, we can do this for any object. But all the object must start at the same time, moving in the same direction over the equal distance, which is not a practical situation we see. But we got to know whoever covers the distance in the shortest time, the equal. So this time it is equal distance covered in less time. So what we are looking at, people, either equal distance covered in in more time. Which distance is covered? That is, either you are covering more distance in less time or you are covering same distance in more time. That will give you the faster and the slower. So here we got, by this activity of the vehicles, the 9 cars racing, we got to know which is faster and what is not.